When we talk about building digital infrastructure, there's always this massive architectural debate. Like, do you build one colossal towering skyscraper where everyone lives and works in the exact same building, sharing the exact same elevators?
Or do you build a sprawling city, right, where everyone gets their own custom-built house, but then you have to figure out how to build the roads to seamlessly connect them all?
Exactly. That's a perfect way to look at it. And for you listening, welcome to today's deep dive, where we're going to explore a network that actively decided to build the city.
Yeah, they completely rejected the skyscraper model.
Right. So our mission today is to take the AVAX crypto, deeply explain the mechanics behind its recent evolution, and really map out how it managed to slash network deployment costs by like 99.9%.
Which is just an absurd number when you say it out loud.
It really is. I mean, we're unpacking the Avalanche 9000 upgrade, the pivot to isolated layer 1s, and how this ecosystem is somehow capturing the attention of both hardcore Web3 gamers and traditional Wall Street giants at the same time.
It's a weird mix, right? Gamers and bankers.
Totally. And just to set the stage for everyone, we're pulling from a few key sources today. We've got the technical docs from the Avalanche Builder Hub, specifically looking at ACP-77 plus institutional research from CoinStats, AI, CMCC, and some deep dive analyses on that Avalanche 9000 upgrade.
Right, because to really grasp why Avalanche is attracting, massive institutions like JP Morgan and BlackRock alongside high-throughput video games, you have to kind of unlearn traditional blockchain architecture.
Right, because it doesn't look like a standard monolithic chain at all.
No, not at all. It operates fundamentally as a three-headed system. That's the primary network.
Okay, let's break down that three-chain architecture, because I feel like that's the foundation for literally everything else we're going to talk about.
Yeah, it's crucial.
So instead of forcing every token transfer, every smart contract, every validator action into one congested lane, Avalanche divides the labor, right? You have the X chain, the C chain, and the P chain.
Exactly. And that division of labor is all about isolating state. So the X chain, or the exchange chain, it's exclusively designed for asset creation and simple peer-to-peer transfers.
Just moving stuff around.
Right. And what's really critical here from a technical standpoint is that it uses a UTXO model.
Okay, wait, I want to pause on that UTXO model because it's a very specific choice. Like, most modern smart contract platforms default to an account-based model, right? Which essentially acts like a global spreadsheet tracking everyone's balances. So why stick to UTXO for the X chain?
Well, it comes down to state contention and parallel processing.
Meaning what, exactly?
Meaning, in an account model, if 10 people try to send transactions to the exact same address simultaneously, the network has to process them sequentially.
Oh, to make sure the global balance is updated correctly step by step.
Exactly. It creates a bottleneck. But a UTXO, an unspent transaction output model, it tracks discrete chunks of value. Think of it like physical cash.
Like digital dollar bills.
Right. If I hand you a $5 bill and someone else hands a different $10 bill to another person across the room, those two transactions have absolutely zero overlap.
They don't affect each other at all.
Exactly. The network can process them in parallel. So by dedicating the X chain purely to UTXOs, Avalanche creates this highly optimized environment just for moving value from point A to point B, no execution overhead at all.
That makes a lot of sense. And then you have the C chain, or the contract chain, which handles the complex stuff, right?
Yeah, the C chain is the EVM compatible one. That's where the DeFi ecosystems live, where NFTs are minted and where you'd connect like a standard Web3 wallet like MetaMask.
Got it. And the third one?
The P chain, the platform chain. This is basically the metadata and management layer. It coordinates all the validators, it handles the staking of the AVX token, and it keeps track of all the custom networks.
Well, ones they used to call subnets.
Right, which we now call Avalanche L1s. So you have these three specialized highways. But the real engineering trick is how they get thousands of distributed nodes to agree on things in milliseconds.
Right, the consensus mechanism.
Yes, no-man consensus.
Which is a complete departure from the traditional Byzantine fault tolerance, or BFT models, we see everywhere else.
It really is.
Let's use an analogy here for the listeners to clarify how Snowman's repeated random subsampling actually works in the real world.
Oh, the stadium analogy is great for this.
Yeah. Okay, so imagine you're standing in the middle of a massive stadium with like 80,000 people, and you need to figure out if the crowd is cheering for the home team or the away team.
Right.
In a traditional BFT consensus mechanism, you basically have to walk up to every single person in that stadium and ask them individually. And this is the crazy part. Every person would have to check with every other person to confirm they all heard the same thing.
Which is just a communication nightmare. That quadratic overhead is exactly why traditional networks hit a scaling wall. As you add more validators, the number of messages required just grows exponentially.
It just bogs down.
Completely. It doesn't scale to tens of thousands of participants without getting incredibly slow.
But with random subsampling in Snowman, you don't ask 80,000 people. You pick like 20 people at random. If the vast majority of them are cheering for the home team, you can be statistically confident the whole stadium is leaning that way.
Right. And then you just repeat that random sampling process a few times, incredibly fast.
And within milliseconds, you have rock-solid mathematical consensus.
Exactly. It creates this system of probabilistic finality that operates in under a second. The network just converges on a single truth rapidly because the communication requirement for any one node stays small.
Whether there's 1,000 validators or 100,000.
Yep. It just stays constant.
Okay, but I want to push back on this whole multi-chain philosophy for a second because, look, we're seeing incredible throughput numbers from monolithic architectures like Solana, right? Where they just process everything in one unified state.
Sure, yeah.
So isn't running 3 separate chains at the base layer and then tracking all these custom L1 environments on top of that, isn't that just overcomplicating the plumbing? Like, why not just build the ultra-fast skyscraper?
I mean, the monolithic skyscraper is highly efficient for composability. Every app can interact with every other app instantly because they're in the same memory space.
Right.
But it introduces systemic fragility. You get shared fee markets and localized congestion.
Oh, like when a hyped NFT mint breaks the network?
Exactly. If a highly anticipated collection launches on a monolithic chain and attracts a massive wave of bots, the compute resources for the entire network get strained.
And suddenly fees spike for everyone.
Right. Whether you're trading millions in stable coins or just trying to vote in a DAO, your fees skyrocket.
So it's like traffic jam on the 5th floor of the skyscraper forces the elevators to shut down for the entire building.
That's exactly it. Avalanche's architecture isolates those fault zones. If a wildly popular DeFi app launches on the C chain and causes a massive traffic spike, it doesn't crash the P chain.
The validators can still coordinate.
Right. Staking functions perfectly, and the foundational layer is totally unaffected. You're isolating execution environments to ensure predictable performance.
Which makes total sense for stability. But, and this is a big but, while the 3-chain architecture solved the congestion issue, it historically had a massive barrier to entry.
Oh yeah, the cost was astronomical.
Right. For a long time, deploying your own custom network on Avalanche's subnet was prohibitively expensive. Which leads us directly to the Avalanche 9000 upgrade, and specifically the Etna hard fork from December 2024.
Yeah, Etna was a fundamental paradigm shift for their economics.
Okay, let's unpack this. What exactly changed?
Well, before this upgrade, specifically before a proposal called ACP-77, if you wanted to launch a custom subnet, your validators had a huge hardware and capital burden. They didn't just validate your custom chain.
They had to validate the entire primary network too, right?
Exactly. They had to run the heavy server hardware to process all of the main C-chain and X-chain traffic on top of whatever your specific app was doing.
Which sounds incredibly inefficient.
It was. And the capital requirement was even worse. To validate the primary network, each of your nodes had to lock up a stake of 2,000 AVSX.
Whoa. So if I need, say, 8 validators for my little indie game.
You were looking at locking up 16,000 AVIX. Depending on the market, that was hundreds of thousands, sometimes millions of dollars in upfront capital.
Just to turn the lights on.
Right. It completely priced out startups and indie devs.
But then ACP-77 eliminated this. They basically decoupled the custom chains from the primary network.
Yes. Subnets were rebranded to Avalanche L1s, and under this new model, if you launch an L1 for your game, your validators only validate your specific L1.
They don't touch the primary network's traffic.
Nope. And instead of locking up 2,000 AVX, they just pay a continuous localized subscription fee to the P chain to keep the L1 registered.
And that fee is tiny now, right?
Very tiny. We're talking a starting fee of roughly 1.33 AVX per month.
That is, I mean, that's an infrastructure revolution. You go from buying a physical server farm upfront to paying a predictable monthly cloud fee. Deployment costs literally dropped by 99.9%.
And when you couple that with ACP-125, which dropped the C-chain's minimum base fee from 25 NAVX down to just 1 NAVX, they essentially commoditize block space.
But wait, if anyone can spin up an L1 for virtually nothing, doesn't that just create a massive vulnerability?
You mean fragmentation?
Yeah. If my game is on one L1 and a decentralized exchange is on another and they can't natively talk to each other, haven't we just built a bunch of isolated walled gardens?
That was always the Achilles heel of the multi-chain vision, right? And historically, the industry solved this by building external third-party bridges.
Which are notoriously dangerous.
Huge honeypots. You lock an asset on chain A centralized relayer mints a wrapped version on chain B. Hackers love them. We've seen billions drained from bridge exploits.
So how does Avalanche avoid the honeypot?
They bypass the third-party bridge entirely using interchain messaging, or ICM, and this teleporter tech introduced in the Durango upgrade.
Okay, let's break down how teleporter actually moves data without a bridge.
It leverages the P-chain as a universal notary. Because every Avalanche L1 is registered on the P-chain, the P-chain inherently tracks the active validator set of every single L1.
Okay, so it knows who's allowed to validate what.
Exactly. So if a smart contract on L1A wants to send a message to L1B, the validators of L1A sign that message using BLS cryptography.
Right, Bohnlin-Shechem signatures, which, for the listeners, basically allows you to aggregate multiple validator signatures into one single, easily verifiable proof.
Precisely. So that aggregated signature gets submitted to L1B. L1B then queries the P-chain and just says, hey, are these signatures actually from the active validators of L1A?
And the P-chain confirms it.
Yep. The message is verified natively at the protocol level. No wrapped assets, no third-party relayer, no honeypot contract. You just seamlessly route liquidity or data across chains.
So they're isolated in execution, but unified in communication. Which brings us to, and here's where it gets really interesting, the real-world adoption.
Yeah, the two very different worlds colliding.
Right, because you've got heavily regulated TradFi institutions wanting this isolation for compliance, but then you've got Web3 gaming studios who couldn't care less about compliance. They just want the throughput. Let's look at TradFi first. JP Morgan's Onyx platform is using these evergreen L1s for portfolio management. BlackRock brought their BUIDL fund over. Franklin Templeton brought FOBXX.
Right, because a traditional public blockchain is permissionless, which is a non-starter for a global bank.
They can't legally deploy a fund where sanctioned wallets can just randomly interact with them.
Exactly. But an evergreen L1 lets them enforce strict node-level compliance. They can implement geo-restrictions like ensuring transactions only process if the users are verified U.S. residents.
And they can whitelist the validators themselves.
Yep. They get all the efficiencies of blockchain settlement without breaking federal law.
Plus, we can't ignore the regulatory shift that made this possible. In March 2026, the SEC and CFTC jointly ruled that AVAX is officially classified as a digital commodity.
That was the institutional green light. It put AVX in the same regulatory bucket as Bitcoin. If you're a fund manager, building on a network that might retroactively be labeled a security is a career-ending risk.
The March 2026 ruling completely de-risks the plumbing.
Exactly.
But then you pivot to gaming. Nexen is building MapleStory Universe on a dedicated L1 called Genesis. Gonzilla Games is running their Battle Royale off the grid on the GN L1.
Because games don't need KYC. They need zero lag and cheap fees. You can't wait 12 seconds for a transaction to process when you pick up a digital weapon in a shooter.
And your fees can't suddenly spike to $5 because some meme coin is blowing up on the C chain. It's kind of like, think of a shared monolithic blockchain, like a chaotic mega cafeteria. You're shouting over everyone, waiting in the same line, and if a food fight breaks out at the DeFi table, you're getting hit with collateral damage.
That's a great way to picture it.
But an Avalanche L1 is like renting a private dining room in that same restaurant. You use the same kitchen, the Avalanche infrastructure, but you set your own dress code, control the guest list, and keep the chaos out.
And that private dining room analogy even extends to the currency you use to pay the bill. The GUN L1 uses its own native token for transaction fees.
Oh, wow. So they don't even use AVX for gas?
Nope, which completely shields their players from crypto market volatility. If AVX doubles overnight, the cost to trade an item inside off the grid stays completely stable.
Okay, but this brings us to the most critical question. So what does this all mean for the tokenomics? If an L1 can process thousands of transactions using its own custom token, doesn't that strip the AVX token of its utility?
Well, we have to look at the dual mechanism for supply. AVX has a hard cap of 720 million tokens. It's a definitively scarce asset.
Right.
There are inflationary rewards for validators, but there's also a deflationary fee burn. 100% of the base transaction fees on the primary network, the X, C, and P chains, are burned, permanently removed from circulation.
And just for context, as of August 2026, the market cap is sitting around $2.77 billion, trading at roughly $6.34. But they aren't just coasting on current throughput, right? They're prepping for insane scale with the Avalanche upgrade.
Yeah, AVAX is designed to push these custom L1s to an entirely new echelon. They're targeting 100,000 to 140,000 transactions per second.
Which is mind-blowing. How do they even achieve that?
By implementing decoupled state machine replication, or DSMR.
Okay, let's unpack DSMR. Because in a traditional blockchain, processing is highly sequential, right? A validator takes a batch of transactions, executes them to prevent double spending, updates the state, and then replicates that state to other nodes. Step A, then step B, then step C.
Right, and that sequential execution is the ultimate bottleneck. The network is only as fast as the most complex smart contract in the block. AVAX fundamentally decouples the replication of the data from the execution of the state.
Okay, so it's like a restaurant kitchen separating the order taking from the cooking. The waiter rapidly takes down orders for 50 tables and instantly hands the tickets to the kitchen. That's the replication.
Yes, the network guarantees the transactions are ordered and securely stored.
And then multiple chefs can actually cook the meals or execute the state changes in parallel, slightly later.
Exactly. By guaranteeing data availability first, validators can process the execution in parallel chunks without waiting sequentially. It removes the bottleneck, which is how you jump from thousands of TPS to over 100,000.
I have to circle back to my utility question. Because if AVAX enables a gaming L1 to process 140,000 transactions a second, and every single one is paid for with the game's custom token, AVAX isn't being burned there, so why hold AVAX?
Because that assumes the L1 operates in a total vacuum. Remember that continuous subscription fee we talked about? The one required to keep an L1 active on the P chain.
The 1.33 AVAX a month.
Right. That fee is paid exclusively in AVAX. So even if the L1 uses a custom gas token internally, the node operators validating that L1 must maintain a continuously depleting AVAX balance on the primary network.
Okay. And if that balance hits zero?
They're deactivated and the L1 halts.
Wow.
So as the number of L1s scales to hundreds or thousands, the baseline demand for AVAX to keep those networks alive scales directly with it. It's a localized tax for the infrastructure.
And I imagine as these isolated economies communicate through teleporter, AVAX is the default routing asset, right?
Exactly. It's the liquidity pair tying it all together. If you want to trade from MapleStory to a JP Morgan L1, AVAX is the universal reserve currency facilitating that exchange behind the scenes.
Is the economic glue. Well, synthesizing all of this, I mean, Avalanche has really executed one of the most significant pivots in network architecture. They stopped battling for space in a crowded skyscraper and just built the foundational roads for a sprawling city instead.
From the raw speed of Snowman to the cost slashing of Avalanche 9000 to an environment where Wall Street and Web3 gaming can actually coexist.
True global scaling isn't about forcing everyone into the same pipe. It's about giving them the tools to build their own pipe and making sure the protocol connects them flawlessly. Which leaves me with a final kind of provocative thought for you listening. If this vision of infinite, customizable L1s truly succeeds, if every corporation, game studio, and government agency spins up their own bespoke blockchain, do we eventually reach a point where the concept of the blockchain becomes completely invisible?
Oh, that's an interesting thought.
Right. Like, will AVAX simply become the TCP/IP of the new financial internet? Yeah. Just the foundational plumbing moving trillions of dollars, entirely unseen by the people relying on it every single day. It's definitely a paradigm shift worth watching closely. Thank you for joining us on this deep dive.